Good morning, good afternoon. Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to today's DevOps.com webinar, Running Stateful Apps Across Hybrid Cloud Environments. My name is Sharon Florentine. I will be your moderator today. We have a great webinar on tap for you, but before we get started, I have some housekeeping items I need to go over. Today's event is being recorded, so if you miss any part of it, you will be able to watch it again. If you just want to be able to review it, you'll be able to do that too. We will be sending out a link to access the webinar on demand following, so make sure to keep your eye on your inbox. We are taking questions from the audience throughout, so if you've got a question, please go ahead and put that into the Q&A section on your console. We're going to set aside some time at the end of the webinar to go through those. So get your questions in and keep them coming. We've got a polling question we're going to start off with today. So you'll see that pop up on your screen. We'd really appreciate it if you could take a couple seconds and give us your answer when that happens. And finally, at the end of today's webinar, we are going to do a drawing for 4 $25 Amazon gift cards. So make sure you stick around and see if you are a winner. With that, I am going to introduce our speaker today. Arvind Gupta is a solution architect with Diamanti. Arvind, thank you so much for joining us today. And I see we've already got our polling question here up on the screen. So let's see what the audience says. Where do you deploy your stateful applications? Only on-prem, only in the cloud, hybrid cloud, but mostly on-prem, hybrid cloud, but mostly cloud, or true hybrid cloud. You don't care where it's running. So this is an interesting one. We're going to give the audience a couple seconds here to weigh in, and then we will look at the results and see what we've got. All right, let's see if we've got these answers are rolling in. Thank you all so much. I'm going to give it another couple seconds here. All right. Well, I'm going to get started looking at the results here so we can move right along. It looks like the majority of the audience is deployed in hybrid cloud, 41%, followed up by, sorry, I lost the poll. Where did it go? 41% hybrid cloud, 24% hybrid cloud, mostly cloud, 29% only on-prem, 6% only in the cloud, and 0% true hybrid cloud. That's pretty interesting. What do you think of those results, Arvind? Does that kind of track with what you were expecting?
Yeah, thanks, Sharon. Absolutely, this is what I was expecting. So I see most of like 41% plus 29% is mostly hybrid cloud or on-premises. And cloud percent is only cloud is 6% and hybrid cloud, but mostly cloud is 24%. So you can see that I think at least more than 50% are focusing on-premises with a hybrid cloud flavor in it, right?
Cool.
And
well,
there is a certain reason.
And let you continue with your presentation. Sorry.
Absolutely, yeah. So so there's a certain reason which we are definitely going to discuss in this webinar today. So if I can find my mouse, okay. All right, guys, so my name is Arvind Gupta. I'm a solution architect with Diamanti and helping our customer to grow, helping our customer to perform better. So we just had this poll, and the result of poll is quite visible, that which says that 41% are running on hybrid cloud, but mostly on premises, 29% only on premises, and 24% hybrid cloud, but mostly cloud, and 6% only cloud. So, and there was another question, another part of the question which says true hybrid cloud where you don't care where it's running. So we're going to talk about how these results are actually matching with what my thought process is, and why we're seeing this kind of results and how the shift can happen. So to start with, at the moment, if you look at the industry trend, there are three major industry trends you will be seeing, whether it's a stateful application, whether it's any kind of workload out there, right? So first one is containers and Kubernetes are driving the cloud native digital transformation. So everybody's trying to ride on this new wave of containers and Kubernetes, changing the way they have been working. And I think you don't need to talk about why containers, why Kubernetes. I believe most of you already understand that as of now. The second trend is industries now moving from a single cloud or single on-premises architecture to hybrid cloud architecture. Or more interestingly, I can say that not just hybrid cloud, now it's distributed hybrid cloud. What that means is you don't want to stick to just one on-premises or one cloud. You want to be able to move your application and data from maybe edge to core to your data center to your public cloud. There's so many possibilities, so many places your data, your application can live in. And that's where distributed hybrid cloud comes into the picture. The third most important thing is data. So now you have lots of IoT devices, lots of AI, ML, and big data workload going on, right? So we are generating a lot more data now. You have maybe electric cars, cameras, continuous data generation, and you need to act upon that. So your data is much more important now. The speed of processing is much more important now. You want to process data faster. You want to get your result faster, so the response to these IoT devices are much faster. So these are the three major trends we're seeing in the industry at the moment. But as data is such an important factor, and we're talking about hybrid cloud, we're talking about containers, Kubernetes, digital transformation, right? So in all that, it's important to make sure that your I/O cannot be a bottleneck. And if you look at the cloud native application landscape, it will look something like this, that at the bottom of this, there's a cloud native infrastructure, and it's moving from on-premises to cloud. And as you guys answered in the poll, not too much of stateful applications are on cloud, and reason is performance and cost, which we'll talk about later. But when you're talking about distributed hybrid cloud across the edge, across the multiple data centers, public cloud, on-premises, that is a basic building block of cloud native applications, right? That you need an infrastructure to run on. But beyond that, other two important aspects which we have already talked about is containers and Kubernetes. So they are the future, and these are the way how you want to move forward, whether it's your DevOps, whether you stateless application or stateful application. But at the moment, there's still some resistance for running these applications on Kubernetes, on containers. And again, there are certain reasons which we'll discuss later. And on top of that, you have application data services, where you want your data services or maybe databases as a service. You don't want to worry about how you deploy it, how you configure it. All you want to do is you want a self-service interface where you can just simply deploy those and start using it, right? So infrastructure and underneath, we'll talk about it, but containers and Kubernetes, why those are important, and how containers and Kubernetes are moving towards the stateful applications. So if you look 5 years back, Kubernetes was starting to begin. But at that time, there was no support or I should say there was no good support for stateful application. So everybody used to think that Kubernetes or containers are all about stateless application. Even now, lots of people have the same misconception, but that's not true anymore. And 5 years ago, it started with Flex Volume plugin, and actually Diamanti was the contributor. Diamanti came up with a Flex Volume plugin and contributed to the open source Kubernetes, which actually opened up the new era of the stateful application on running on Kubernetes. So this way now, many storage vendors are able to plug in their storage capabilities to the Kubernetes. Now that Flex Volume plugin has evolved into container storage interface, which is CSI, and it has, with this, there is no limitation now. You can do anything you were used to doing with storage, with data, and now it's much more automated, much more organized using the container storage interface in Kubernetes. So when you're talking about stateful applications in Kubernetes, there are a few building blocks which Kubernetes provide out of the box. So for example, storage class support, you can define what kind of storage you want, maybe fast storage or slow storage and those kind of thing. And then you have persistent volume support. Originally, Kubernetes did not have persistent volume support. You might want to, like 4 or 5 years ago, you might have to mount the volume from the host and it's shared, non-performing. There are lots of issues, right? So persistent volume and persistent volume claims are the Kubernetes way of creating and managing the volumes. Then stateful sets are the way Kubernetes manage the stateful application. So this is a Kubernetes terminology, which is for managing the lifecycle management of the stateful pod. And it automatically adds a DNS entry per pod via native service, and it automatically provisions the volume and allow the scalability as well. So as you want to scale, it can scale your data in addition to the application itself. Then Kubernetes also have something called scheduler extension, which is which allows other vendors around the Kubernetes to bring more intelligence to the Kubernetes. So, for example, we at Diamanti, we have built lots of intelligent scheduling, which is based on the container network and data and storage, so that we can place the application where it should be based on the storage bandwidth, based on the storage size, and based on the network bandwidth. And there are lots of inbuilt intelligence. Then CNI is container networking, which is very, very important when you're talking about any stateful application. It's not you just writing to the data. You need to access it. You might need to replicate it. There's lots of stuff involving there. So CNI is also important. Then another beautiful part of Kubernetes, which is operators or application data services, which allows you to bring any database or any data services as a service. So basically it's a full lifecycle management of application, and it's the responsibility of the vendor. So for example, MongoDB has their own Kubernetes operator. Minayo have their own Kubernetes operator, right? So each of these are coming up with their own Kubernetes operator, so that you don't need to worry about how you deploy. You don't need to worry about intricacies of Kubernetes or containers at all. For you, this becomes just simply like as a service. You can even build a UI or web interface on top of those, and actually some of them already have web interface or UI for that. So it becomes a truly as a service interface for a normal user, who don't need to want to get into the details of how you deploy. All you care, okay, I want maybe 1 terabyte SQL Server storage, SQL Server database. That's it, right? So all this functionality comes from Kubernetes, but for running a stateful application, there are lots of things which are really, really important from the infrastructure itself. For example, you for any stateful application, backup, snapshot, cloning, or maybe mirroring across the synchronous mirroring for high availability, encryption, load balancing, quality of service when you're running multiple application on same infrastructure. All those kind of things are very, very important when you're considering running your stateful application on Kubernetes or on any cloud native infrastructure. So when you have something like this, the top part is usually provided by Kubernetes or Kubernetes operators themselves. But for bottom part, you need a kind of infrastructure or kind of a platform which spans across hybrid cloud, so that not just you don't care about how your database is deployed, you also don't want to spend too much energy or too much time to figure out where you want to deploy. So if you have a hybrid cloud platform like Diamanti, it can help you to mitigate all those problems. And this is where the triangle, the pyramid shape also fits in. That top two portion are provided by either Kubernetes operator or the developer themselves. But the bottom three layers are part of, should be the part of a full-fledged platform, and Diamanti is one of them. We'll talk about that in more detail. So as I mentioned, Diamanti is end-to-end solution for stateful application. And if you guys are familiar with Diamanti, the way Diamanti started, and similar to the poll result here today, that almost 29% running on premises, 41% running on premises with focus, running on hybrid cloud, but focus on premises, right? So that's why we came up with this bare metal HCI platform, hyper converged infrastructure, where we offloaded the storage, we offloaded the networking to PCI offload card, and this was a hyper converged infrastructure with local attached storage. So it's a super performing hyper converged infrastructure, and it was purpose built for Kubernetes, purpose built for containers, providing you the quality of service. So if you guys are familiar with Diamanti, you will know that the whole aspect of this hyper-converged infrastructure is high-performance Kubernetes platform. So, but later on, most of the people don't know yet that how Diamanti has transformed itself from just the hardware-focused appliance to a software-focused hybrid cloud model. Now we have ported this same Ultima offload architecture to the software only, so that when you move into the hybrid cloud, the things, the reason most of the people responded that you're running on premises, because that's where you see the performance guarantees. That's where you able to see the SLAs and all those kind of things, right? So now our whole point in this hybrid cloud architecture is to bring the same performance, or at least similar performance, may not be same because offload have its own benefit. So we bring in the same similar performance to the software running on any Kubernetes, running on any location, whether it's a telco, edge, on premises, whether it's any cloud, maybe AWS, Google, Azure. Also support any kind of hardware. So you can run Ultima as a software now on bare metal, running maybe with any OEM, Intel, Dell, Lenovo, HP. And also not just supporting the local attached NVMe storage, we started supporting many other form of storage like MU, Fabric, external storage, cloud storage. So overall, this whole platform, which was able to give amazing amount of performance, and we'll talk into more detail, is now ported to the software, and this software version can run on any cloud. So this gives you the freedom to get a uniform or common platform to run either on premises or public cloud or any non-Diamanti hardware as well, and still able to get most of the benefit of this kind of platform. And most importantly, this is a common platform. You don't need to worry about how you're running on public cloud, how you're running on premises. This gives you similar interface all across. And then on top of that, we have built a product called Diamanti Spektra, which is our hybrid cloud, multi-cloud management plane to manage all these heterogeneous infrastructure all around the globe. So you can manage your infrastructure or platform, whether it's Diamanti offload version or HCI, or it's Diamanti software running on any hardware, any cloud, or any Kubernetes. You can manage all of them, everything together at once. So this is just an overall benefit picture of the Diamanti platform, where Spectra provides you the global management plane for policy access control, cluster lifecycle across any cloud. You can create clusters on AWS, on GCP, and manage them from just this similar interface. Multi-tenancy is very important for all enterprises. Metrics, observability, lifecycle application lifecycle management, app and data mobility, which is very important, and we will talk into more detail about that. Which the app and data mobility is something which is very unique to Diamanti, and you won't be able to get anywhere else, because this was built into our DNA when we started with in a hyperconverged infrastructure. Now, this app and data mobilities are actually provided on top of Ultima hybrid cloud data plane. So with the Ultima software or embedded version running on either on public cloud or either on hardware, we're able to expand the capability of our hardware platform to the software, to the public cloud or any hardware, and provide all those basic requirement for a Kubernetes platform. So for example, CSI, CNI, and like CNI is layer 2 and layer 3, both together with the integration of the storage CNI. And our container native distributed storage CNI is very popular for its many benefits, and we'll talk about that. Then provides you security, data protection, and management. And on top of that, you can accelerate in on-premises using our IO offload card. So I don't want to spend too much time on this, and let's go a little deeper, where you can see that what this kind of infrastructure brings is massive scalability. So as you can see in this at the bottom, with the Kubernetes, with our hyperconverged infrastructure, or maybe even in the software virtualization, you are able to scale within a node. You can virtualize your volumes, you can virtualize your network, and Kubernetes allow you to virtualize your application in containers and scale within a node. But beyond the node, you can scale it across multiple nodes, multiple zones, and multiple clusters. But even beyond that, now you have with Diamanti Ultima and Spectra together, you have capability to scale your application across on-premises, edge, and cloud altogether, and giving you a uniform interface, a common interface to manage your app on top of it. So this kind of gives you independence from hardware, independence from software, independence from the cloud itself, or independence from the location where it's running from. So when we're talking about stateful application running not just on a single cluster, we're talking about running across hybrid cloud. There are lots of functionality we have built together across the Diamanti platform, talking about Spectra or Ultima altogether, or maybe on-premises hardware acceleration. What we provide is multi-layer of data protection, which is very important for any stateful application. So if you're talking about running within a node, we provide encryption, snapshot capability. On top of that, when you're running an application within a single node, you can recover using a snapshot, right? But what if that node fails? For that, we provide the mirroring capability, where we provide a synchronous copy of your volume or your data, and it's everything I'm talking about here is container granular. So we're talking about volume, which is directly mapped to the container. So you can mirror your volumes, which is mapped to your stateful application container, across a zone or across the node. So if one node goes down, or maybe one failure availability zone goes down, Your data is completely secure in other location, whether you're talking about around the node, across the node, or across the zone. So in that case, Kubernetes can simply move the application easily from one node to another node and continue from where you left off. So this gives you high availability with zero downtime, uh, zero RPO, and zero RTO. Beyond a zone, or when you're talking about within a cluster, so you can do the mirroring across the zone or across the node, and then you have backup capabilities also. So you can back up your data to the cloud, to your NFS back location, or wherever you want to. You can back up all your volumes and recover from there. So as you can see, it's as we're moving away from a node to zone to a cluster to multiple cluster or regions and cloud, Diamanti provide protection at each level. So you can have multi-level of protection, so your data is never lost. And as you go beyond the cluster, across the multiple cloud, multiple regions, then you have capability for backup, migration, and DR. So you can set up a DR cluster with Diamanti so that your all the volumes running on a clusters, or you can choose. When I'm saying all, it doesn't mean all. You can pick and choose which volume you can decide, and then all those volume can be asynchronously cloned across the region to a different cluster. And if the whole region goes down, let's say something happened, what happened to OVG recently, the fire, right? Your data is secured across the region in another cluster. All you need to do is click a button on Diamanti, and it will migrate everything from one region to another region for you. So you have both option. Either you can do migration where your data is not originally asynchronously copied, but you can copy your application and data both together to another region, another cluster, another cloud. You can copy your application and data from maybe public cloud to on-premises to public cloud, and migrate them easily. Maybe your QA cluster is running on public cloud, and now you want performance, so you're coming to the on-premises. You can migrate everything from public cloud to on-premises easily with the migration capability of Diamanti Spektra platform. Similarly, you can set up a disaster recovery plan so that your data is being continuously being copied to another site. And if something goes bad, you can simply fail over to another site, and your all the application, all the data is already there and running. So these are all the capabilities which are very, very important for stateful applications. And if you guys would like to see a demo of this, I'm not gonna showcase it right here, right now, but you can follow through this link, which talks about how you can deploy, migrate, and do the disaster recovery for stateful applications across the hybrid cloud. So we talked about how Diamanti puts everything together, but what do you expect from a cloud native storage? Yeah, data protection is important, right? So the data protection is one of the important feature which we have talked about, but you also need to worry about the performance, and that is the main reason today's poll suggested that most of the people are running on the on-premises infrastructure. And you also need to take a look at all the features provided by the cloud native storage, which you're trying to use, because now you moving to containers and Kubernetes. You cannot work with legacy storage software. You need to move on, right? So when you're picking a cloud native storage, you need to look for certain features. For example, what is the CSI compatibility with Kubernetes? How easy the dynamic provisioning is, how easy the scaling of your storage volume, and whether it's external or local attached, how you manage all that scaling. And tiering is also important, right? You are running multiple application on a single node because it's a virtualized environment, whether it's a VM or container. It's a virtualized environment. When you have multiple application or multiple stateful application, it's very, very important to make sure you're getting your SLAs. One application cannot impact the performance of other application. So that tiering is important. Who's getting the faster performance, who's getting the slower performance. You should be able to set automatic policies. And then you also need to take care of hybrid cloud data mobility, or maybe edge to core data mobility, data protection, and the form factor. Cost is also important, that where it fits, how it fits, right? So let's focus on the performance and why it's very, very important. The reason is the answer is in the poll questions. Everybody is running on premises. I should say, like, most of the people, not everybody, is running on premises because of the performance. So it's very important that your IO cannot be bottleneck anymore. And when you move to regular, usually on public cloud or maybe virtual infrastructure, that is the biggest problem. Your IO is always bottleneck. Your CPU is waiting for IO to complete. So there's some key performance indicator which you need to look at when you selecting your container native storage. First thing is, these days, NVMe SSD is the bare minimum requirement. You need to support, or you need to look for a storage system which not just support NVMe SSD, it should be optimized for NVMe SSDs. Because most of the storage vendors out there are still optimized for spinning media, and spinning media cannot perform. Right? So another thing is, when you're talking about shared storage, like NFS and all those things, they cannot perform at scale. They're remote storage, so latencies are so high. So in that case, you need a distributed storage. Like in case of Diamanti hyperconverged infrastructure, or even the cloud setup, we're able to give you local attached NVMe storage, which is distributed across multiple nodes. So you have capability of fast local storage, as well as the remote storage, as well as all the data protection capabilities. So, and even if you're using remote storage, it's important how you accessing the remote storage. You need very, very low latencies. And one of the important aspects you need to look at, that when you're accessing your data using this storage subsystem, IO wait time should be near zero. And if your IO wait time is not near zero, your storage subsystem cannot perform. Latencies, you need to look at microseconds, not millisecond. Millisecond is not acceptable anymore. IOPS, you need to look at millions, not thousands. Thousands are not acceptable anymore. With massive amount of data, high-speed data transaction processing, it cannot sustain with millisecond latencies and thousands of IOPS. Then when you running your storage, if it's running on software, it's using your CPU, it's using your memory, it's contending against your application itself, right? So how you bring it down to zero? And hardware acceleration is the answer to that. Volume level QoS is also very, very important, because when you're running, again, as I mentioned earlier, when you're running in shared infrastructure, your volumes are competing against each other. Your applications are competing against each other. You want to protect them against each other. You don't need to do over provisioning of your infrastructure. You don't want to say, okay, my one database is very critical, I'm not going to deploy anything else on this particular node. If you do that, you're increasing your TCO, you're increasing your footprint. You want to compress everything to minimum number of nodes, minimum number of infrastructure, and still able to extract most out of it. So with saying all that, when you talk about Diamanti performance, in case of whether it's hyperconverged running on premises hyperconverged infrastructure, or we have hyperconverged software running on public cloud as well. So in that case, you can run local attached NVMEs on the public cloud bare metal, just like the way you're running on Diamanti or any hyperconverged infrastructure on the on premises. Yet we are able to give you the full data protection, so that most of the people are worried about using the local attached NVMe storage on public cloud, because it does not provide you the data protection. You shut down your instance, your data is gone, right? So with Diamanti, you get full data protection. even on the cloud. And with that, we are able to give you 1 million IOPS even on the cloud, not just hardware platform. And we're able to give very minimal latencies of 100 to 200 microsecond, and IO wait time you will see is close to 0. So to prove our data, whatever I have said in the previous slide, we have asked McKnight Consulting Group to do some performance benchmarking on Diamanti platform and various flavor of it. So a couple of things we did is we ran same performance benchmark on Diamanti hardware hyperconverged infrastructure Diamanti HCI platform, which is on premises with our offload capability. Then we ran another experiment on Diamanti software running on just bare metal. No hardware acceleration, just Diamanti software running on top of Kubernetes on a bare metal infrastructure. Then we ran another experiment with the Diamanti software running on AWS bare metal instance. So if you see in this the first diagram, the first three, where it's all about Diamanti, whether it's running on HCI, whether it's running on software version on bare metal, or it's running on public cloud, it's able to give you consistent, good performance. Then we did some experiment running same benchmark on rest of the public cloud. For example, AWS best, at least when we did this benchmark, the best storage system was IO2 with Nitro cards. So in those cases, we ran IO2 as a storage subsystem and running Kubernetes on top of AWS Nitro instances. And then we ran same benchmark and we saw that Diamanti is able to give 4 times better performance compared to AWS. And it's independent of where it's running. So it's able to give 4 times better performance even when Diamanti is running a software on top of AWS itself versus AWS using the EBS IO2 volumes. Similar performance result we saw whether you're running on AWS IO2, IO1, GP2 is anyway lower performance, and you can see that it takes way longer to complete the test. And similarly, Azure Ultra, Azure Premium, we try to run with best of Azure, best of AWS, and we were easily able to be between 4 to 24 times faster. You see 24 times faster here because we have removed one on-premises competition here. We don't want to name that, but we are able to perform much better there. Then another experiment we ran with scale factor 300, and even then you can see that Ultima or Diamanti Ultima software running on AWS bare metal instances was able to perform 4 times better than AWS Nitro, even in that case. So as your load is increasing, as your scale is increasing, Diamanti software is still able to perform much better than your existing cloud infrastructure. And performance are really excellent for any stateful application. This is specifically for SQL Server, Microsoft SQL Server. So you can see that Diamanti is able to give performance all across, whether you're talking about your Diamanti HCI or any hardware or even the public cloud. On the right side, you can also see that we able to run OpenShift on top of Diamanti HCI and give the similar amount of performance acceleration. So if you're an OpenShift user, we work with any Kubernetes vendor. We're neutral to what Kubernetes version you're using, what Kubernetes distribution you're using. We're neutral to that. We just rely on open source Kubernetes and plug into any other Kubernetes distribution and able to accelerate them underneath. So these are some proof points and which showcase that how Kubernetes, how Diamanti's architecture is important to bring those kind of amazing performance. And as you can see on the top left, we are able to hit 1 million, almost 1 million IOPS in case of same benchmark. So these results are from same benchmark which McKnight did. And you can see that we're able to get really amazing performance, really high IOPS compared to anybody else. Similarly, we're able to demonstrate near zero IO weight in case of Diamanti, and while for everybody else it's super high. On the bottom left, if you see that latencies are uniformly low, with independent of load factor. So you can see scale factor 100 versus 300. So again, just to, I think I didn't mention, this is TPCH benchmark. So this is more IO intensive, IO heavy benchmark. You can see that even with the load increase, the latencies are not increasing that much. Even with that high load, completely stressed out system, million IOPS, you're able to get 200 to 230 microsecond average latencies. And on the rightmost side, bottom right, you can see that we're able to give you quality of service. So these are, I think, multiple 27 pods of SQL Server running in parallel. And even with that, we're able to give you, it's the same SQL Server pod, same HammerDB benchmark pushing the data. But with that, we are able to give you the quality of service isolation. So some of them were running with high performance tier, were able to give more IOPS and bandwidth, whatever they have been assigned to, compared to medium, which was assigned lower bandwidth for networking and IO as well, and compared to best effort. So best effort is almost getting nothing. So this way you get you get opportunity to if isolate your critical databases, your critical services, critical application from non-critical, and still you can run it on same infrastructure. So this is just to summarize what we have talked about, that this kind of performance also results in significant TCO reduction. So as you can see, Diamanti is way cheaper than any other competition out there when you talk about public cloud versus Diamanti. Similarly, this is another TCO calculation we did for comparing to run same similar amount of IOPS or similar performance requirement, how much you need to run on AWS without Diamanti and with Diamanti. So left side is with Diamanti. As you can see that your cost is $3,000, almost $4,000 per month. On the right side, the cost to achieve same amount of IOPS, same amount of number of CPU, you need to pay almost 10 times of it. Leftmost, just to clarify, it's a bare metal instance on EC2. On the right side, it's 2x large instances with the EBS volumes. And I think this 64K IOPS with IO2 instances. So if you add up all the math together, that's how Diamanti is able to provide you much higher performance with single instance running on AWS, and still able to give you like almost 8 to 10 times better TCOs. And on top of that, with EBS, whatever you have available is basic persistence, right? With EBS. With Diamanti, you get all the functionality which we have talked about the data protection, which is replication across any cluster, any cloud, migration, fault tolerance, availability zone, and all those kind of things we can apply on top of this architecture and make sure your data is protected. And that's how we're able to give you true hybrid cloud environment where you don't need to worry about how exactly your data is, where your data is, how your data is moving. Only thing you need to worry about the cost on public cloud you're paying to move your data, because it's paid per byte, right? So just to summarize, and how we able to get this kind of amazing performance, whether running on premises or running on public cloud, Diamanti have optimized for NVMe SSDs with SRIO word selection. We support other storage subsystem, but it's on top of NVMe itself. So that's one of the key secret sauce of giving this kind of performance. We do sequential write. We don't have any garbage collection. We have very low metadata. We have thin provisioning, zero copy snapshots. So with all that, your overhead of the storage is so low that your performance goes exponentially high. And as you can see in the previous charts. And another thing is performance and TCO. The QoS has the biggest impact. The quality of service we're providing with Diamanti, as I showcased in the case of SQL Server. With that, with this kind of quality of service, you can achieve millions of IOPS per node. You can achieve really amazing performance, yet you can control who gets that kind of performance. You can control that on the running of same node, same infrastructure, my critical databases or my critical stateful application will be able to utilize the high performance tier, or you can pick and choose what exactly that means, how much IOPS you want. You can say that, okay, my critical database, I want at least 500K IOPS, or I want 5 gig of bandwidth reserved. So we do the minimum guarantee so that you able to make sure that any noisy neighbor is not impacting the performance of your critical database. So this gives you a massive amount of TCO, so massive amount of footprint reduction, because you don't need to do over provisioning of your infrastructure. You can run more containers, more application in less footprint. And on top of that, when you're decreasing your data center size, when you're decreasing number of instances, obviously you're gaining a lot, because you're able to you're paying less for that. So QoS and performance together brings a really great amount of TCO saving, which we saw in the previous slides. So that's pretty much it from my side. And as I mentioned that in a previous slide, you can go to the demo where we talk about how really we able to move your stateful application, deploy, manage, migrate, and set up the DR policies on your stateful application running on any cloud or on premises or anywhere, maybe edge, maybe telco, maybe core, or wherever it's running. So that's how we're able to give you true hybrid cloud capabilities. And that's how we're giving a great amount of TCO. So I think that's pretty much it from my side. And Sharon, do we have any questions or
We sure
anything?
do. We sure do. Thank you so much, Arvind. That was awesome. All right, so we do have a couple minutes here for Q&A. All right, let's see here.
Yes, I would highly recommend, if you guys have any question, please feel free to put it QA right now.
Absolutely, we still have plenty of time, so don't hesitate. Get your questions in here so we can get them answered for you. First of all, we've got a question here from Dinesh Kumar, and they would like to know, I'm assuming, and forgive me if I get this wrong, how is this similar to Rancher, or is it similar to Rancher?
Yeah, so you have very good question. I would say it's similar to Rancher, but it's not similar to Rancher. Only similarity with the Rancher is a part of what we provide, which is multi-cluster management. But on top of that, we have what Diamanti provide is a full stack Kubernetes solution across your hybrid cloud. Rancher is providing mostly to ability to manage multiple cluster altogether, yes. But how do you move your stateful application from one cloud to another cloud? How you set up the DR? All those kind of feature, data protection features are built into our data plane. And that's how we are way different from Rancher. And I'm biased, but I would say way better than Rancher, but it's up to customer to decide, I would say.
Okay, thank you. Just a couple more here. if Diamanti Ultima software is performing this well, what's the point of having the offload?
Yeah, so I think for that, I would like to go back to my previous slide. And if you look at this particular slide where we're talking about Microsoft SQL Server performance on scale factor 100 versus scale factor 300. So this is TPCH, where your scale factor is relevant to how big your database size is, right? So bigger the database size, bigger the scale factor. So as you can see on the right side, left side, for the scale factor 100, when still it's IO intensive, but it's not completely stressing out the number of CPUs available or IO bandwidth. So in this case, you can see that Diamanti D20, which is the hardware offload, as well as let's look at Ultima with Nitro, Diamanti Ultima software running on Nitro, are able to perform pretty much similar. And even Ultima on Nitro AWS is a little bit faster because it's not apple-to-apple comparison. It's different SSDs and more CPUs available on the AWS side. But as you look at the right side, when scale factor is moving up, even though Ultima running on AWS is 4 times faster than AWS with IO2 volume, still you can see that Diamanti D20, which is with the hardware offload, is able to sustain, is able to still give like 2 times better performance than running Ultima software on AWS, because this is the point where you start seeing so just to be more clear, that when you're running software on top of your host system, so and that what I mean is your storage stack, your networking stack, when you're running as a software on host itself, you're using CPUs, you're using memory, right? So once CPU and memory and IO subsystem start getting stressed out, that's where you see the difference why you need offload. As you can see in the second case, when it's a heavy load, your CPU are stressed out. With hardware offload, your networking and storage stack is not dependent on your host CPU. So in that case, we're still able to give you much better performance in case of hardware offload. But going back, it depends on use cases, right? In lots of use cases, scale factor 100 kind of workload may be good enough for you. So here, software works as good. But if you looking for more scalability on the performance side, yes, that's where offload will be helpful.
Okay. I think we've got time for one more. So let's see. Do I need to buy Diamanti servers or offload cards to achieve this kind of performance for stateful applications?
So yeah, as I said that I think probably this answer the question is it depends on what kind of performance and what kind of workload you're trying to run. In certain cases, absolutely, you don't need to buy Diamanti server or offload cards. In that case, software only solution is good enough. But if you are really running IO intensive, heavy workload, highly scalable, that in those cases, absolutely, offload is useful. Offload is very, very important in that case.
Okay. Well, thank you so much, Arvind. All right, folks. So just a quick reminder that today's webinar has been recorded. So if you missed any or all of it, you are absolutely able to watch it again. We will be sending an email with a link to access the webinar on demand. But you can also go to devops.com/webinars and look in the on-demand section if you want to find that after the fact. So now, the moment you have all been waiting for, we are going to find out who the winners are of our Amazon gift cards. All right. Let's see. Winner number 1, Brian M. Congratulations, Brian.
Woohoo.
Yay. Next, we have Martin C. Congratulations, Martin. JW. Congratulations, Jay. And finally, Brisa, I hope I'm pronouncing that correctly, Brisa D. Congratulations to all our winners. We will be reaching out to you via email to get your gift card to you. So make sure you check your inbox. If you don't see the email, make sure and check your spam folder.
No gift card for me, Sharon?
I'm sorry. I was hoping I would win too.
Yeah.
Maybe next time. We'll get lucky.
Absolutely.
Well, thank you so much again, Arvind, for that amazing presentation. And thank you so much to the audience for spending the last hour with us. We really enjoyed it, and we hope you did too. So thank you so much.
Thank you very much.
I'm Sharon Florentine, signing off. Thanks. Have a great day and stay safe.